Hey guys, this is Einar. I hope you're doing great today and welcome to your 27th tutorial in basic statistics in Excel. Now so far we've been talking about correlation coefficients between variables at a nominal and an ordinal scale, but this time we're moving on and we're talking about correlation coefficients between variables at an interval and a ratio scale. And two examples of those types of variables is a little example I've constructed here. This is the number of Facebook friends a person has, and this is the number of AFK, which means away from keyboard, i.e., IRL, some people would say, friends that you have. Now my theory here would be that if you have a lot of Facebook friends, you tend to have a lot of AFK friends as well. How do we measure this? Well, one way of doing it is using the so-called Spearmans R, or rank correlation coefficient. It was invented by this guy, Charles Spearman. Just click the link and you'll find out more. And it's based on the idea that you sort your data set first by the X variable and then by the Y variable. You rank these values for each observation, and then you compare these ranks. So we're going to get right to it and start doing that. I select my data, I go into custom sort, and I choose to sort it by my X variable. So we have the smallest number of Facebook friends up there and the highest number of Facebook friends down there. I start typing in my ranks. We go there. And we move all the way down, and we ranked our values for the X variable from smallest to largest. We have to do the same thing for the Y variable. So we do that. We go to custom sort, we choose the Y variable there, and we rank it just like we did with the X variable. And we go down all the way here. See, all the way to the end. Now there's a problem here. You notice here that we have three people that have 4 AFK friends, but they have different ranks. So before we start talking about the theory of what we're doing, I think we should deal with this problem. How do we give all of these people the same rank? Well, what we could do is we give them an average rank and give them all the same average rank, so they'll be represented by a common number. So what we do is we call these observation ties because they are tied together. They have the same value, and we have to give them a new rank. So we have the value 4. And what we're going to do is we're going to add 3 plus 4 plus 5. Now in this case, I'm going to write parentheses and I'm going to write in the numbers 3 plus 4 plus 5. And then I'm going to divide it by 3, which is the total number of numbers we're comparing. Why am I writing numbers and not just selecting the cells that we've done before? Well, when I select the cells and then go back to the values and change the ranks, it's going to have an effect on the calculations we've done here. Now it's not going to have a real effect on these results because it'll still be the same. But I don't like the idea that we're changing the data while we're working with it in that way. So I prefer to just use these numbers in this case. Okay, so we got a new rank for these guys, and it's going to be 4. And we have another example of this, 5. The value 5 needs to be dealt with, so we're going to write parentheses 6 plus 7 plus 8. We're going to divide that by 3. 7. So we give all of these people with 5 AFK friends the rank of 7. We do the same thing if you have 6 friends, and then we're going to have to add 9 plus 10 divided by 2 because we have 2 observations, and we get 9.5. So they have 9.5 rank. There we go. We need to do the same thing for people with 8 friends. So we go there, we write 8 equal to a parenthesis. We have 2 observations in there, 12 plus 13 divided by 2. You see, I have to do this for all of our cases here. Oops, sorry about that. That was my phone. There, 12.5 there. You can just calculate along with me while I'm doing this. Go 14 plus 15 divided by 2, 14.5. There we go. People with a value of 10. So we go equal to parentheses 16 plus 17 plus 18 divided by 3. And they get the rank of 17. We have people with a value 11. So we go here. Oops, sorry about that. There. And we calculate 19 plus 20. We divide it by 2. And we get 19.5. There. 19.5 for both of them. We have the value 13, so we write that 13 right there, and we have 2 of them, and they have the ranks 21 and 22, so we're going to find their average. 21 plus 22. God, this is tedious, isn't it? Divided by 2, and we get 21.5. 21.5 for both of them. And finally, two people with a value 15 there. So we go equal to a parentheses 24 plus 25. Oh, dear God. And we got to exchange their values there, so we write 24.5. Excellent. Okay, now we've compensated for the fact that we have ties in our data set, so it looks like this. Now we can talk a little bit more theory, but to make it really clear for you guys, I'm going to custom sort this by the serial numbers. There we go. Okay, so what we're saying is if you have a lot of Facebook friends, you will have a lot of AFK friends. What if that was true and we had a correlation, they vary together, so a low value here, we have a low value there, what would that mean in terms of our rank and our rank differences that we're going to calculate now? Well, we find a person here, for example, who has very few Facebook friends. He is ranked very low in his variable. And the same person also has a very few AFK friends. He only has one. So he is also ranked low in his AFK friends. So if you calculate the difference for this, it's going to become a low difference. And let's say that was true for all the materials, that the difference is very low. It seems that they vary together. A lot of people with a lot of Facebook friends have a lot of AFK friends and vice versa. Well, that would mean that this number, D2, here will become a low number. And if you have a low number on the top of this equation, you will also have a low number for the ratio itself. And if you take 1 minus that, you get a very high number. And it varies between 0 and 1, I could mention, where 1 is a very strong correlation and 0 is a very weak one. So if we have a very small number here, because of the small differences, we're going to get a strong correlation, which is, intuitive. It works with the theory that they're varying together. That should give a high value for a correlation coefficient. So let's start calculating it. Gosh, this is going to be a long tutorial, guys, but it has to be. I don't know how to shorten it down any. So there, we're going to subtract all of our ranks. We pull it down like this. Now we need to raise them by 2. There. Now why do I raise them by 2? Well, if we go down here and we write sum. Oh, I must have caps lock in there. And I write sum here. And I sum up our data set. Like that. We get 0. So that's, you might remember that problem from when we were working with the standard deviation. We can't work with that material if we're summing up something that turns into 0. So we need to raise it by 2 in order to remove all the minus signs that we have in our material. We are ready to actually start calculating now. So I'm going to write sum, because we want the sum of all the distances raised by 2. Like that. We're going to need our n, because that is in this part of the formula. So I'm going to equal to, and I'm going to count the number of observations. I can select the x or the y variable. It really doesn't matter. It's the same number of observations. We get 25. And let's start building our little formula here. So we go 1 minus. Let's put 2 parentheses. We don't need them, but I want to be extra clear about this. 6 multiplied the sum of our distances squared. Close the parentheses. Divided by n multiplied by n and square this n. Minus 1. And we close all of our parentheses there. So that's what the formula looks like. Let's hit enter. And as I guessed, we have a high correlation. So it seems like my idea is true. If you have a lot of Facebook friends, you tend to have a lot of AFK friends. Now, of course, I made up these numbers myself, so of course my hypothesis will be true. But this is the way you work with data in reality. If you want to say you have a relationship between 2 variables, you have to prove it somehow. And these measures are one way of doing that. Now, this tutorial is really long, so I'm going to, cut it short now. I wish you good luck. Try sticking in some new variables here, changing the distances, and see what effect it's going to have on the RS. And I wish you good luck and have a great day. Bye-bye.